Good morning. I'm Dolphy Gilpin coming to you from the Comfort Inn at JFK International Airport, Comfort Inn. And this morning we have already done two sessions on our PDM, DLS, SLS outputs being now applied to solving circuit analysis problem. Circuit analysis by the mesh process, the mesh analysis process. And for this, we had projected a specific 5 by 11, 5 by 12 matrix. And we did or applied the PDM methodology, and we have derived down to the 2 by 2 matrix, which is corresponding operators. These are the operators, LL star 05 in this case, which is using this fifth row, using the fifth row here, the LL 06 81 15 35 star. Alright, so we apply the methodology. We got to this matrix, LL star 05, and this matrix. And we were only, because we're not trying to prove the PDM output anymore, the infinite series output, we just leave the steps in the 2 by 2 instead of generating serials from the 3 by 6 here, which we usually do. We further apply the PDM methodology and got to the 2 by 2, the paired 2 by 2. I know we say that in our mesh analysis we're going to be using these outputs from the PDM methodology as input parameters to our mesh circuits, and so therefore this could have represented some series circuit in which the determinant of the matrix will come out with some current or some voltage value. So here we took the determinant of this 96, 65, 75, 19 matrix, which is should be 99 rather, which is the matrix with the corresponding operator of the LL star 7183. So we took the determinant and we got this, and we got the negative 305.54, and we, for example, take it as being amperes, and we know that the amperes 3 minus negative 505 3054 could have been 3054 milliamps, it could have been 3054 microamps, and it could have been 3054 megaamps. It could have been amperes, milliamps, or megaamps, depending on all the elements. If all the elements were in the mega or the micro, the elements were in micro units, then the answer would come out in microamps. If all the elements were corresponding in amps units, then the answer would come out in amperes. If it was in megaamps, it would come out in megaamps. And we note here again that the 35, the minus negative sign is saying to us that the current, the assumed current direction is opposite to the derived current. Next we do the determinant of the 3106 7519, 3106, which is the one corresponding with the operator of LL star 7105. And we get 99 units. This could have been 99 microvolts, 99 volts, 99 kilovolts, megavolts, depending on how the elements were arranged in the mesh analysis. Okay, so 99, this is positive. If it was 99 amps or microamps or kiloamps or just amperes, and that will be determined by how we consistently or systematically set up our mesh analysis problem. Now, the determinant of this 31069965, here it is, and we got 1421. Check these by your computer or by your calculators. I did these by my head, and sometimes, the arithmetic mistake is made. Check these by your calculator. And the last one was 83060565, the determinant of this 2 by 2 paired matrix. And we get 883. This unit again could be amps, volts, or microamps, megaamps, kiloamps, microvolts, kilovolts, depending on how the elements are arranged in the 2 by 2 period. Okay, well, we will show in future sessions the direct application of these matrices in the solution to mesh analysis problem. We're going to be integrating, bringing in the Thevenin's equivalent, the Norton's equivalent circuit, the Thevenin's equivalent circuit, and we're going to be using setting up a mesh, going around the circuit via a mesh analysis method and applying the mesh method. We will still be using the Kirchhoff current law, the Kirchhoff voltage law in all these, and we'll get some answers systematically and consistently as related to the mesh analysis method. Note here that this is the same thing could have generated our infinite serials or frictionless serials if we wanted to generate frictionless serials from these. We'd start from here, and we could say this. I could have done it mentally. 99 star 71 83 99 19. That would be one. 99 star 71 83 65 75. That would be another one. LL star 71 83 75 65. That would be another one. LL star 71 83 99 19. That would be one. LL star 71 1999. Then we move on to the 05. That would be LL star 71 05 31 19. LL star 71 05 06 75. LL star 71 05 19 31. LL star 71 05 75 06. We can move on to 31 and we get LL star 71 31 31 65. LL star 71 31 06 99. LL star 71 31 65 31 and LL star 71 31 99 06. We will move to the 75. LL star 71 75 83 65. LL star 71 75 06 05. LL star 71 75 05 06 and LL star 71 83 65 and 65 83. But we are not here generating the series, infinite series, 1 by 11s and 1 by 12. We are using the determinant of the pair 2 by 2 to be input parameters in the solution of our mesh analysis method. So next time we will actually set up the circuit with our elements, voltage, currents, and inductors and capacitors and Thevenin's equivalent voltage and Norton equivalent circuits, currents, and we'll do the mesh analysis using 2 by 2 matrix, using 4 by 4s, and using other determinants of other matrices. So once again, I'm Dolphy Gilpin, and I'm closing out this session on our amazing 5i arithmetic. Notice the many ways it's applied to in many fields and in many ways to bring about solution to various problems. You ever using it in electrical engineering to solve circuit problems via the mesh analysis.